Hey guys, welcome to the Coders Bridge. Today we will be starting with a new playlist, deep learning. So in this playlist we will be seeing like how a deep learning is deep learning model is created, and like what are the different methods like we can create a model, like what exactly the neural network is, like what are the like libraries we will be using, and many things. So this playlist will be consisting nearly 30 plus videos. So this is just an introduction video of deep learning and what are the tools we are going to use in developing a deep learning model. And like in future videos like of the deep learning, so there will be more practical interaction as well as with theoretical interaction. A deep learning is a concept where we can say deep learning is a subset of artificial intelligence where we need a basic knowledge of machine learning, which is regression, classification, what is regression, what is classification, and like what is optimizers and what is activation functions. Like we need the basic knowledge of machine learning and a very basic knowledge of Python, like how we need to handle files, how we need to handle images, what is like NumPy, what is pandas, and what is pillow library. So like this we need the basic Python knowledge. And will like in upcoming videos we will be seeing like how statistics and probability will be helping us to uh, make our deep learning models like pretty accurate. And we'll start with the introduction today. So normally deep learning, as I told, is a subset of artificial intelligence. Like why deep learning is introduced is like normally our human brain, like for example, if we see a object, just consider like if we are seeing a mobile phone, like how our like our brain identifies like this is a mobile phone, like this is a black color mobile phone. So the entire combinations of neurons, they like our brain consists of neurons, right? So that, as you can see in this picture, right? So our brain consists of many neurons and axon terminals. So like that our brain will send signals through neurons to our cell body, and the cell body gets activated and it will pass the information to a axon. When like the same, if you see over here, so this is a human brain architecture. We can say it's a neuron architecture. Yeah, this is a deep learning model architecture. So normally in this part, if you see, the eyes are seeing some content, like just consider like I'm seeing, like we are seeing a mobile phone. Okay, we don't know, like if we haven't seen it before, so if you are seeing it for first time, just consider our eyes will be seeing this object as a um, this thing as an object, and it will be sending information to our neurons. From neurons it will be passed to a excuse me, it will be passing to the cell body, and there a cell body will like identifies the object based upon the size, the shape, the color, the width of the screen. And so if you are seeing two mobiles in the same time, one mobile is small and one is a very just consider one other one is a tablet. So we our brain is able to differentiate between mobile phone and a tablet. So the only difference between both the thing is the size of the thing. So the similar way our deep learning models will also like they are trying to imitate the human brain behaviors to process the data, to create the patterns between the objects, or in some scenarios like in we have in some of the problems are like decision making problems in real world itself. If you take, right, just consider a Tesla auto pilot mode. So the Tesla car needs to understand the object which is in front of the car, whether it is a dog, whether it is a car, or whether it is in red light. So if the cars are in a traffic signal, it needs to read the like it needs to understand. So obviously all the colors are lights only, right? So if it is a red, we need to stop. If it is green, we need to move on, like correct. So in that thing, the deep learning model should understand the coordinates. So normally machine readable language is binary language, correct? So machine can only reach the content which we gives as an input in a binary format. So the colors will be read in a binary input through the color codes, which is RGB, correct? So similar way, how we read the objects, like we see, okay, this is green color, this is red color, the machine reads the green color and red color in the form of a binary conversion. Okay, so this is a basic introduction. What is deep learning? Deep learning is nothing but it's we like the machine is trying to mimic the human brain, like how humans make decisions, how humans connect things, how human create patterns, how human brain does everything. The similar kind of thing deep learning model will also try and help us to like make our work easier. Okay, let's come to our next slide. Like, what is deep learning? We saw what is deep learning. Now we will be seeing like what are the different deep learning techniques we have. Like normally deep learning is nothing but a neural network, combinations of neuron. As I told before in this slide, we have combinations of neuron informations, like all the neurons, all the, so here the neurons nothing but the nodes or the information which we get, correct? So we have three different types of deep learning techniques. The one is artificial neural network, convolutional neural network, and recurrent neural network. So in the name itself you can see, right, like neural network is nothing but multiple nodes or multiple combination of nodes. It's known as a deep learning model, correct? So in artificial neural network, so we'll see here what is like normal artificial neural network, right? We will be having a combinations of neurons. Okay, we'll see here. So here you can see, right, network input, it's nothing but information is given or feeded to the model. Just consider we are predicting some okay, we'll take in this, we have some input data set from a healthcare domain. Like we have a like 1.4 million sets of data of a cancer patient, of the cancer, like x-rays and other like reports and every stuff. Okay, so our model needs to predict like what will be the cancer, like how much percentage of the body is affected in upcoming 4 months or upcoming 6 months, correct? So in that thing, the network input will be the scan reports or the like worksheet database which the healthcare domain will be providing to this input. Network input is nothing but the input which we use to feed to the model. For example, it just considered like human brain. If we are seeing any new object, we are reading the object, like we are seeing or we are understanding the object from our eyes and passing the information to our brain, right? So in the same way, we will be providing the input to our neural network in the form of text, in the form of images, in the form of audio, or like in the form of what is that, numbers, time series data. It may be anything. So okay, in artificial neural network we will be having hidden layers. So we will be seeing a separate video on like a neural network. This is just an intro video of deep learning, so we will be not seeing, we will be not going much deeper into this. So in this thing, just try to like get the information from the picture itself. So we are passing some input over here. These are known as neurons. Okay, and the circles which are highlighted in green color, these are known as hidden layers. So as per artificial neural network technique or architecture, the inputs and the network output will be segregated with hidden layers. It's not mandatory like we need to have only this much of hidden layers, we need to have only one hidden layer, two hidden layer, or we need to have seven hidden layers. So hidden layers are like it's the kind of hyperparameter tuning. So if you say in layman word sites, it's completely based on trial and error method. So we can eliminate, just consider in the first model run, like you are just implementing with 5 hidden layers, you are getting around some 84% of accuracy. Like you need more accuracy, like you need to at least touch 95 to 97%. So you are increasing two more hidden layers. So before we have 5 hidden layers, now we will be adding two more, and now we are processing with 7 hidden layers, correct? So the hidden layers are completely a trial and error method. So doesn't worry about hidden layer. The input will be passed from the neurons to the hidden layers, and here hidden layers we will be having some technique called weight and bias. So I will be creating a separate video for AN. In that we'll be discussing the intuition or mathematical part of like what is weight, how the bias is calculated, how the weight is calculated for the particular neuron, and so on. So in this artificial neural network, the data will be going forward. Here you can see, right? Just follow the arrow marks. Network input, like we are feeding some data through neurons. It is going and like touching all the hidden layers. So here you can see, right? One neuron will be connected to all the hidden layers. So in that same way, all the hidden layers are connected to the output layer. Okay. And again, this output layer, here you can see, right, the hidden layer, we have a one more arrow here. It is saying like some back propagation. So it is nothing but it is a technique to reduce the error or to maximize the weight. So I told you, right, we will be initializing some weight to all the uh, neurons when hidden layers. So in that thing, to decrease or to minimize the loss, we need to change the weights of every neurons on based upon the propagation. Propagation is nothing but one go and one back. So here we are going forward. This is forward propagation. This is backward propagation. So normally when we are doing a back propagation, we will be changing the weight. So for weight changing, we will be completely seeing the theoretical part based upon formulas we have, like what are the formulas we will be going, what is the equation to change the weights, and so on. So this is just an architecture how artificial neural looks like. We will be giving the input through neurons. They will be hidden layers, and to minimize the loss, and we will be changing the weights in the back propagation technique at the end, like when the like the loss is minimum, or we will be using at the end we will be using some activation functions to minimize the loss as well. So at that time we will be getting a like output which is, so we have many what is that technique to get the output. So we'll be seeing that completely in an new like a separate video of artificial neural network, the max intuition behind that, and completely. Okay. Okay, so let's come back to our other technique, which is convolutional neural network. As I told you, in artificial neural network, we will be working with the hidden layers, but in convolutional neural network, we will be instead of hidden layers, right? Here we will be having filters. So normally, convolutional neural network is mainly used or used for image classification technique. Like normally, if you want to classify any image, just consider just take our example of our Google search. Okay, so there's a two technique of searching in content in Google. Like either you can write in a text, or either you can send a like upload an image to search the particular thing, right? So if you are just uploading the image and clicking on enter, sorry, search, you will be getting similar kind of images as your search result, right? The same kind of thing, like we are sending input, like how to say, like we are sending our image as an input, and we are we are predicting like what the image is, and or instead of predicting we can say it like we are like coming to a conclusion, like okay, so as per this image here you can see, right, we are sending an image which is 28 cross 28. This is the dimension. 28 cross 28 is nothing but it is a dimension, and here we have one, right? The one indicates this is a black and white image. If here we have three, that indicates this is an colored image that represents the RGB color coding. Okay, so here you can see, right, we are passing the image 2 over here, and this is an handwritten image. We are passing to channel, which is here we have here we have one convolutional layer, which is convolutional filter, and we have another max pooling layer, and we have to like another convolutional layer and another max pooling layer. Then we are flattening the output layers, and then we are predicting like what is the image which we passed. Okay, let me just explain you this entire flow. Normally, as in this artificial neural network, input will be passed, and here will be updating the weights in front and back propagation for each what is that, hidden layers, right? So the same thing here, instead of hidden layers, we will be using convolutional layers. What is convolutional layer? Convolutional layer is nothing but it's a similar kind of hidden layer. So here, right, we will be mm, we will be just taking the portion of a, like how to say, in convolutional neural network we will be having a combination of max pooling and a convolutional layer. Normally max pooling is nothing but we will be so here you can see, right, it is 28 cross 28. That means our image is of 28 pixels. Okay, in 28 pixels, what this convolutional neural network will be doing is we will be like multiplying each filter, like each layer with this filter, which is 12 cross 12. For example, we have 28 cross 28, correct? So our max pooling we will be here you can see, right, 2 cross 2 max pooling. In 2 cross 2 max pooling, in 28 cross 28 we will be having 28 what is this, rows and 28 columns. This is a matrix, correct? 28 cross 28 is a 28 cross 28 matrix. So max pooling layer is of 2 cross 2. In this 2 cross 2, we will be first taking 2 cross 2 matrix and finding the maximum value of the 2 cross 2 matrix and saving it in a new matrix, correct? And again we will be just striding one position. Based upon the striding, we will be initializing the striding is nothing but how, like how much coordinates we need to jump. Okay, so we will be seeing, as I told before, we will be seeing the complete convolutional network video and how much position we need to jump from the first 2 by 2 matrix to second 2 by 2 matrix. And the second also we will be taking the maximum. So normally pooling is nothing but to how to say, we have like three different kinds of pooling. Maximum, like max pooling, min pooling, and average pooling. Maximum pooling, like it will, like we will be taking the as you can see here, right, we will be taking first 2 cross 2 matrix and finding the maximum value in it. Then we will be sliding based upon the sliding value. Okay, um like it will be indicates the object much accurate, nothing but like how to say. So okay, you can just take a 9 and 8. Okay, 9 and 8 doesn't, okay, instead of 9 and 8 we can take 3 and 8. Okay, 3 and 8, it's nearly same only. Okay, only you can see, right, in if you write just 3, right side of the 3 will be curve part. For 8 also it will be curve part. Okay, if you are using max pooling, right, the our model will be pretty much accurate to identify whether it is 3 or whether it is 8. Okay, so as I told before, you're right, we can use n number of hidden layers. It's completely based on our wish. The only part is the how many hidden layers have been included, that much computational power and that much cost will be included in the particular model for training. Okay, so here also we can use n number of convolutional layers and max pooling layers. It's completely based upon a computer, like how much GPU is there in your machine, or how much computational effort you are taking. Sometimes many models can take hours, months and weeks to get trained. Okay, uh, um, at the end, right, so once all the convolutional and max pooling layering is done, we will be flattening the layer. Flattening is nothing but converting. So this is all a 2D layer array. Okay, this is 2D. The element is, all the arrays are 2D array. So we will be converting this 2D array to a single dimension array. That's why we are using flattening layer here. And here we are using dropout. Dropout is nothing but as I told you, right, mm, so in the name itself you can see, right, we are just dropping out some elements. Just consider when we are taking this pixel. Okay, so this is like 28 cross 28 pixel. Okay, in first channel, like we are taking a 24 cross 24 and we are applying max pooling over here. When applying max pooling of 2 cross 2 matrix, we formed a what is that, a new layer or a new how to say, updated layer of 12 cross 12, correct? So like this we will be going till flattening layer. Flattening, at this flattening layer it will be giving, so normally our output will be of 10 elements, correct? 10 elements is nothing but we are identifying a handwritten number, whether it is 2, whether it is 1, whether it is 4. So normally the numbers are of 10 classifications, correct, from 0 to 9. So we have the list over here 0 to 9, correct? So at the end, after flattening, we will be getting 10 to 15 elements. Okay, so at that time we will be dropping some elements to get the accuracy. So dropping is nothing but dropping is a technique to increase the accuracy of the module by leaving some possible like elements at the end of when we are calculating the loss function or cost function. Okay, so here after flattening here you can see right here we are using ReLU activation function. So activation functions of different kinds. We have many activation functions is ReLU, Rekilelu, Sigmoid, Softmax. Like we have many activation functions that we will be seeing a separate video on like why activation function, what is the use of activation function, and what is the Mac intuition behind the activation functions. Okay, after flattening the layer, applying the activation functions, we are using dropout over here at the end. So dropout, as I told you, like we will be dropping out all the some of the layers to get the accuracy of the module. So at the end we will be identifying whether this number which we are given as an input, whether it is 2 or 4 or 5 or 6, whatever it may be. Okay, so CNN is mostly used for image classification thing. Hope you understand like what is CNN, like what is the technique and how the architecture looks like. Okay, the next thing is RNN. RNN is like a recurrent neural network, as I told you in ANN, right? Artificial neural network. So there similar kind of thing is RNN. Okay, RNN is nothing like here we will be having a similar kind of what is that? Input layer. We will be having similar kind of input layer, or input will be fed to the our model, and here we'll be having the hidden layers as I told in this thing, right? ANN, here also we will be having hidden layers. In RNN also we will be having same hidden layers. So the only thing, the only difference between RNN and ANN is here the so here we can see, right, this is one neuron, this is one neuron, and this is so this is a hidden layer and this also an hidden layer. So the back and forth propagation between the two hidden layers will be in a recurrent network, or it will be in a loopy format to get the classification, to solve the classification problem or the regression problem. Okay, so even here we will be updating the weight, we will be calculating the bias by using activation function, optimizers, like by using loss function. We will be seeing like the detailed concept of RNN in a later videos. Okay, so recalling the everything, deep learning is nothing but a subset of AI or artificial intelligence. It's just used to mimic the human brain. So we have three different things: ANN, CNN, RNN. ANN is nothing like we will be having hidden layers. We'll be going like performing our model in forward and backward propagation to get the output. To increase the accuracy or to minimize the loss, we will be updating the weights for each hidden layers. Okay, and for CNN is mostly used for image classification problems. So normally we will be having convolutional layers, nothing but a filters, as well as max pooling, min pooling or average pooling layers to like minimize the errors in identifying the objects or to increase the accuracy of predicting the objects. At the end we will be using flattening layer to converting the 2D array into a one-dimensional array, and we will be using a dropout technique. It's not mandatory we need to use dropout technique. It's completely based upon our how to say, our trial and error. Like if your model is giving high accuracy, that doesn't mean your model is good. It may lead your problem, like your model, to overfitting also. Like I need to explain the two things. One is overfitting, other one is underfitting. Like overfitting is nothing but in the, like when you are running the model for 20 epochs or 10 epochs, your model will be giving you as a, like in like normally epoch is nothing but an uh, front and back iteration. Okay, so in first epoch itself, just consider your in the first epoch your model is giving you 30% accuracy. In the second or third epoch your model is giving you 60 or 70%. So at the end of all the epochs, at the 10th epoch you are getting 96 or 97 percentage of accuracy. That doesn't means like in your model is very accurate or your model is very bad. It completely based upon the what is that, how many layers you are using, what are the technique, like what is the optimize. There are different types of optimizers, like stochasticated gradient descent, um, and Adam optimizer, and how to say, um, and we have RMS prompt. Like we have many different kinds of optimizers to calculate all the this thing. What is that? Accuracy and all. Correct. So it doesn't mean like if your model is giving you high accuracy, it's a good model. If your model is giving low accuracy, it's a bad model. Like it completely depends upon the layers, the dropout layers you are using, how many filters are like you have implemented in that. Okay, overfitting is nothing but like your model is giving a more accurate result than you expected. Like underfitting is nothing but like for example, like you are using only one convolutional as per this CNN model, right? You are using only one convolutional network and your model is not giving any data like output, like it's only giving 30 percentage or 40 percentage of output. Okay. Okay, we see like we saw RNN as well. Okay, let's move to the next slide. Like what are the IDs we are going to use in our deep learning playlist? Okay, so normally deep learning, like we will be using Python as a base. So for ID, if you see right, we will be using three different IDs. One is Jupyter Notebook, other one is Spider ID, and the third one is Google Colab. So normally you don't want to install Jupyter and Spider separately. You can just install Anaconda. So inside that you can able to find Jupyter and Spider. Okay, I'm using Python 3.8.5. Okay, and for Google Colab, why I use Google Colab in the sense for training. So recently, right, I have worked in one CNN problem statement. Like it is around like we have almost 1 million data sets. Like it's around 1.2 million data set. So it's a very huge data set. So for training that we need that much power in our machine to like run those problems, or else it will be taking much time to train our data. So in that thing we will be going with Google Colab. Google Colab is nothing but it's a virtual environment where Google will be providing you a interface, a Jupyter node. It is similar to Jupyter Notebook, like interface where you can run your ML problems in the Google's what is that GPU. So I will be showing like how we can change the runtime in Google Colab and everything. Okay, and the library which we'll be using is TensorFlow with Keras. TensorFlow is the most popular library like for machine learning and deep learning techniques. So we will be using TensorFlow with Keras. So here we are not using PyTorch. We are using like TensorFlow with Keras. And for front end, we will be using Sublime. For HTML coding, we will be using Sublime. So for this Sublime, we will be seeing at the end of this deep learning playlist. So initially, we will be going from basics, like what is the Mac intuition, and till end we will be going and seeing like how to create an end-to-end deep learning